Today's lecture is about two conditions of atom, and that conditions are stable or unstable. Before talking about the stability and instability, we're going to talk about the name of the shells. Now it's the nucleus. The shell that is after the nucleus is called penultimate, and after anti-penultimate the shell is called penultimate, and after the penultimate it comes the outer orbit, and that's called the valence orbit, and that's the orbit in which we can measure the valency or the number of total electron or the ions. These are all measured by the valence orbit of an atom. Here the valence shows the combining capability of valence orbits. Like if the electrons here are unstable, so we can say that the atom is unstable, but if the valence orbit has stable atoms or stable electrons, we will say that it's an stable atom. So let's talk about the stable and unstable. What's unstable? If an atom got the valency, it will call unstable because it has the place to just gain or lose an electron, so that atom is unstable. And the unstable atom will become stable by stabilizing or forming ions. Now, what are ions? Ions are the charges above the element. Element, as I have talked about, element is always neutral. But if then element loses or gains an electron, it will become ion. Now, there are two type of stability stages. First one is called octet and second one is called duplet. I will just talk about it. Let's first talk about this figure. Now suppose that, and this is a nucleus. Suppose that a anti-penultimate at or anti-valence orbit has one electron, and after that it has 2 electrons, 3 electron, 4 electron, 5 electron, 6 electron, 7 and 8 electron. So this is called the duplet because there is a pair of electron in the valence orbit. It's called a duplet. And this one, it has 8 electrons in the valence orbit, and it is completely stabilized. Let's make a figure. Like, just suppose this is nucleus and this is the valence orbit. Oh, orbit is very good. Like, there's electron here, there's electron here. It is duplet because it has 2 electrons. It is also stabilized. It is an stage of stabilized, but it is weaker than the octet. Just let make a diagram of octet first. Now just suppose 1 2 3 4, 1 2 3 4, total 8 electrons. Now, is there any valency left here? No. So it is fully stabilized atom, while the duplet is weaker than the octet because it can be ionized further. It is stabilized, but it can be ionized, so we just say that it is a stage of stabilized, but it can be ionized. So let's just firstly talk about these figures. Why I doubt these figures? Like, just suppose an atom with 1 2 3 and 4 electrons in the valence orbit, and 5 6 7 and 8 electrons in an orbit. Now these type of electrons which has 1, 2 or 3 electrons in the valence orbit will call metals, and it always loses the electron because the proton, like the proton, it just does not have a proper force on it, so it will be loosed. Or if just suppose there is another orbit on it and it has only one atom here, so what will this atom do? This atom will lose this electron to just stabilize. So there's the same condition here. If an electron or an atom want to stabilize and it has 1, 2 or 3 atoms in the or 3 electrons in the valence orbit, so it has to just lose an electron to become stabilized. While if an element has 4 electrons in the valence shell, it is quite stabilized, but it can lose as well as gain electron to just become stabilized. While if an element has 5, 6, 7 electrons in the valence orbit, so it will just gain electron to become stabilized. Like just suppose if this is a valence orbit, like it got 4 and 5. Like if there are 5 electrons in the valence orbit, what it should do? It will just gain an electron to stabilize. It will again gain an electron to stabilize. It will again gain an electron to stabilize, and it will become stabilized. Now that's the point. Okay, so what's the process by which an electron or atom just loses electron? An atom loses electron by the process called oxidation, and an electron gains atom gains electron by process called reduction. Now here's the point why metals just lose electron and non-metals just gain electron, because the metals has 1, 2 or 3 electrons in the valence shell, and non-metal just got 5, 6, 7 electrons in the valence orbit. That's why they do that. Now here's the third point: the more the electron and protons are, the more attraction force is. Now why this is gaining electron and why this is losing electron? The answer is simple. It has less force because the electron is only 1 or only 3, and it will gain electron because the electrostatic force is more, and it will attract the electrons towards itself. Or we can say that, as we know, the number of electron is equal to the number of proton. Here the number of proton will be 1, 2 or 3. Less protons, less attractive force, it will lose electron. More protons, more attractive force, it will just attract electrons. That's the point. Now, how can we just say an electron is oxidated or reducted, or it loses an electron? How can we just show it? Now, just suppose if an atom, that is Na, and that's metal, like before gaining or losing electron, it is just an element. It would just not have any charge on it, so we can say that it's an element, a simple element, nor with the difference of metal or non-metal. So let's suppose this sodium, just after the chemical reaction, loses an electron. When an element loses an electron, the number of proton increases, and proton have positive charge. It just loses 1 electron, so we will just show positive charge. If it loses 2 electron, we will show positive 2. That means it loses 2 electrons. then we will just plus 1 or 2 electron. Now by this way we can just say, or we can show that an ion is developing, or it's an ion that is produced by losing 1 electron. So what in case if an sulfur gains an electron, what will become? It will become S minus. Like it will just become ions of it will become cation that just gains an electron, numbers of electron increases, and it will become minus. The minus sign will show the gains of the electron. And that's the way we can study the atoms stabilization and unstabilization.